Now we discuss the functions of serving gateway in the 4G core network. We know that once an EPS bearer has been established between the user equipment and the 4G core network, then the exchange of user data can take place over this EPS bearer between the user equipment and the 4G core network. Now on the 4G core network side, the entity that is responsible for exchanging uh, the user data with the user equipment, it is the serving gateway. Serving gateway is simply a router, and what it does is that the user data that it receives from the user equipment, it routes it to the PDN gateway, and the user data that it receives from the PDN gateway, it routes it to the respective eNode B, so that from there on it can be sent to the corresponding user equipment. And then we come to another important function of the serving gateway. Uh, we know that an EPS bearer needs to fulfill certain quality of service requirements. Different EPS bearers have different quality of service requirements, and these quality of service requirements are implemented in an EPS bearer using the diff-serve protocol. And as a part of this protocol, the uh, packets that are associated with an EPS bearer, they needs to be marked according to their quality of service requirements. So what serving gateway does is that it inserts those quality of service markers into the headers of the IP packets that are associated with an EPS bearer, and these quality of service markers are inserted as diff-serve code points. Now anchor mobility is another important function of the serving gateway. Suppose this user equipment has established an EPS bearer with the 4G core network, and this would be the data path. This is the data path. Now if this user equipment moves from this eNode B to here, so in that case there would be a handover with this eNode B, and this data path would be switched, and it would be switched like this. But here we can see that its point of contact with the core network, it remains the same. So we can see that here serving gateway is acting as an anchor. So serving gateway acts as an anchor when there is an inter eNode B handover for the eNode Bs that are connected to the same serving gateway. Now when now in another case, for example, this is a base station, and this is a base station of a 2G or a 3G system, and if the user equipment moves in the coverage area of this base station, then there would be handover, but the data path that would be established would still be established through the serving gateway. So here also the serving gateway is acting as an anchor point when there is handover between this different 3GPP systems from 4G to 2G or 3G. Now we come to another important function of the serving gateway. For example, this user equipment is in idle mode, and there is incoming data for this user equipment in this serving gateway from the PDN gateway. Now as this user equipment is in idle mode, it cannot receive data. So this data, this user data would be stored in the serving gateway, and the serving gateway, are in other words, it would be buffered in this serving gateway, and the serving gateway would inform the MME about this incoming data, and this MME would then page or inform this user equipment about this incoming data. So this user equipment would then connect to the 4G network, and after that it can receive its user data from the serving gateway. Now, another important function of serving gateway is the lawful interception. Suppose the law enforcement agencies want to monitor the communications of a user or a user equipment, then they can do it in the serving gateway, because all the data of the eNode Bs that are connected to a serving gateway, uh, it passes through the serving gateway. So it is a good point of interception where the law enforcement agencies can monitor the traffic of a user equipment.